I never know how long to wait until it's going. All right, so we're live. All right, so this is Data Science Club number 6. Today is going to be a little bit more conceptual. We don't have as much code, but there's a nice discussion on Kaggle, the Kaggle Learn page on data leakage. And it's something that we've been talking about, but I don't think we've used the phrase data leakage up until this point. And so we thought it would be nice to kind of take a little break from the code and just talk more conceptually about what this is and run through the examples that they have over there. So we're going to go again to Kaggle.com. We're going to go to this Learn. And then in intermediate machine learning, we click on there, we go down to the bottom. We're going to look at both of these, data leakage and the exercise data leakage. So I already have it pulled up here. There's a little bit of code in here. If you want to run it, you can fork the notebook and you should be able to run the examples in here.
Yeah.
Data leakage, roughly defined, is anytime you're training your model using information that you won't have when you need to be making the prediction. So here on Kaggle, they're talking about two main types of leakage, target leakage and train test contamination. So if you've been watching or participating in the previous notebooks, you've noticed that Ravi and I have talked a lot about the importance of setting up your training database and your testing database separate so that you can test to make sure that you're not overfitting, things of that nature. Now, if you set up your training and test database and you have some of the same samples in both sets, that's this type of contamination. So you can imagine if you're trying to teach a model to predict whether or not a picture is a picture of a dog or a cat, and you have some of your training samples in your testing database and you're overfitting, then you're not going to get a true picture of how well your model is doing because it will have just memorized those training samples.
Yeah, your validation accuracy would be very high, but once you try to implement your model in a production environment, in a place for which you were actually creating that model, at that place it will start failing.
Yeah, so let's go down to where it talks about train test contamination, and then we'll go back up to the target
leakage.
So they actually run an example in here, and then again, if you wanted to run the code, you could actually fork this notebook. This is a Jupyter notebook that you could pull and actually work with. But here, again, they're contaminating their. Oh, well, let's see. Oh, this is an example of target leakage. Let's go back up here. So train test contamination, this is what we were talking about. This is where you want to run a function like train test split and make sure that your testing database is separated from your training database. And then, yeah, I mean, it's really as simple as that.
Yeah. I mean, you just, if you use the train test split function from scikit-learn, it's from scikit-learn, I believe.
Yeah.
And if you simply use that, you should be able to eliminate test train contamination kind of leakage data leakage that you might have. So.
Yeah, and so I mean it's simple, but it's an important concept because if you have all of your data in your training data set, or you have some of your training data set in your testing data set, or some of your testing data set in your training data set, then you could certainly come up with a nice training and validation accuracy to report. But the moment somebody asks you to use data that's not in your data set, you might not have a very generalizable model.
So this is the second one, is the one that we haven't talked earlier about.
Yeah.
So the second type of leakage that you can have is target leakage. Target leakage basically means that you have been training your model on one particular data set, but when you put the model that you created, when you put that model into production, those same data sets might not be the thing that you're getting as an input.
Yeah.
So, I mean, they have a very basic example. I think going through the example will clear it up more. So, this is a table about predicting who will get sick with pneumonia. And there are multiple fields over there. So, there is that, did they get pneumonia? That's our target. It's called target field, right? The one which we are predicting.
Yeah.
And the other ones are
target,
predictors. Yes, and the rest of the fields are required to make that prediction if a person did get pneumonia or not. So one of the fields that you would have noticed is took antibiotic medicine, and that should have 100% correspondence to if a person got pneumonia or not. So if a person got pneumonia, they would take the antibiotic medicine. So if you were just using this data set, you would get very good validation data. You would get a very good model. You would get a very good validation result. But once you put it into production, that particular field, took antibiotic medicines, would not be available for you, because that only gets filled out once a person has got pneumonia and they have been given that antibiotic medicine.
Yeah. And so that's a nice example. I mean, basically, if you're using any data that you can't have, or you only get after you've already determined the prediction target, then that's where you start running into this type of data leakage. So I think it'll be even more clear when we take a look at the exercise that they have in here. So Ravi and I have not gone through these examples. We haven't peeked at the answers, so we might totally get them wrong, and that's fine. So first things first, we gotta import these learn tools here, and so that we can start looking at this. So we've got the setup complete. So this will set up to tell us what the answers were after we decide. All right. So problem number one. Nike or some general shoe company has hired us to save money on shoe materials, and we need to check out this model at somebody's belt to predict how many shoelaces they're going to need to buy. And these are the fields that the model uses to make its prediction: the current month, advertising expenditures, other macroeconomic features, such as unemployment rate, so things not specifically tied to shoes, more just general economic things, and the amount of leather they ended up using in the current month. The results are almost perfectly accurate if we include how much leather was used, but it's only moderately accurate if we leave it out. So we need to decide, is leather used a source of data leakage? So in this instance, I think we're talking about, is it target leakage? Is it giving some information directly about the thing that we're trying to predict? And yeah, I think that's it. All right, what do you think, Ravi?
Yeah, I think this would be a target leakage.
Yeah, I think so too, because there are all these other things. So the current month, we'll always know what the current month is. The advertising expenditures in the previous month, that makes sense, because we'll know how many people, or that should be related to how many people were marketed to. Various macroeconomic features as of the beginning of the current month. That's great. But I think the key word here is the amount of leather that they ended up using
Yeah.
at the end of the month.
I mean, unless and until they have been updating that particular field every day of the month, if, then it might give us some prediction. But even then, it would be it would constitute as target leakage because the definition for that particular field is that how much they ended up using in the current
Yeah,
month.
I mean, if this was the amount of leather used
Till
the
now.
previous month,
Yeah.
then maybe we could use it, but or maybe the month last year. So let's see how we did here. All right, so it says this is tricky, depends on how it was collected. Would you decide at the beginning of the month how much leather will be used? If so, that's okay. But if that's determined during the month, you would not have access to it to make the prediction. And if you have a guess at the beginning of the month and it subsequently changed, the actual amount used during the month cannot be used as a feature. So this is basically what Ravi and I were saying. Because it's worded the amount of leather that was used, then it's data leak. It's target leakage because we couldn't possibly know that ahead of time.
Mm-hmm.
All right. So let's see. So we have a new idea. We could use the amount of leather Nike ordered rather than the amount they actually used, leading up to a given month as a predictor in our shoelace model. Does this change the answer? Yeah, I think it changes the answer. That sounds like that would be okay to use. I don't know. What do you think?
Yeah, that's a tricky one. It would certainly not be a leakage problem, target leakage, because you would always have that value, how much amount of leather Nike ordered.
Yeah.
But yeah,
It
at
may
least
not be helpful.
at least they don't say anything about how does that model do. So
Yeah.
because
Yeah.
I don't imagine it will do so well.
Yeah. So up here, the other thing that was kind of a hat tip to let you know is that they say that the model is almost perfectly accurate. Again, if you have an almost perfectly accurate model, then you should be a little bit suspicious.
Yes.
So let's go down here and let's see how we did on here. Is leather ordered on the previous month?
Yeah, and if
Data
you're
leakage.
And if you're watching the video, please pause before we hit the solution and try to make your own answers.
Yeah. All right. So let's see. They say this could be fine, but it depends on whether they order the shoelaces first or the leather first. If they order the shoelaces first, then you won't know how much leather they've ordered when you predict the leather first. That makes sense.
Yeah. So it's again, the answer is kind of depends on how they have been entering the data.
Yeah.
And that's a big problem or a big part of how data science works, that how the data has been entered into the data set that you are going to be using is always going to be a big thing. So that's the reason why you use features like the stats. It was called stats, right, in Panda? Yeah, I mean, on stats to figure out what the data set is about, and you always have to take a sneak peek at your data and see if everything looks all right or not.
All right. So problem number 3. So this is a cryptocurrency thing like Bitcoin. and we're trying to predict what. Let's see. What are we trying to predict?
The price of a new cryptocurrency 1 day ahead.
Predicts the price. Yep. 1 day ahead. Okay. So his plan is to purchase, blah, blah, blah. The most important features are the current price, the amount of the currency sold in the last day, the change in the last day, the change in the last hour, and the number of tweets in the last 24 hours that mention the currency. The value of the cryptocurrency has fluctuated up and down by over $100 in the last year, and yet his model's average error is less than $1. He says that this is proof his model is accurate and you should invest with him. Is he right? Well, all right, so that makes me suspicious just because I don't think that it's possible to predict commodities things with that kind of accuracy.
Yeah, for me it's the fourth field, change in the currency price in the last 1 hour. And I believe his model is depending too much on that feature.
Okay. All right.
And
It's 24 hours. Yeah.
yeah, I mean, rest of them are still decent in the last 24 hours or something, but the last 1 hour is the one I believe where his model is taking the most out of.
Yeah. All right. Let's see. I'm still a little bit foggy on this one, but I like. All right. So solution: there is no source of leakage. These features should be available at the moment you make the prediction. Yeah. Okay. And they're unlikely to be changed in the training data, but the way he describes accuracy could be misleading if you aren't careful. If the price moves gradually, today's price will be an accurate predictor of tomorrow's price, but it may not tell you if it's a good time to invest. If it's 100 today, a model predicting a price of 100 tomorrow may seem accurate, but it might not tell you whether or not it's going up or going down. A better prediction would be the change in price over the next day. If you can consistently predict whether the price is about to go up or down, you may have a winning investment. All right, that makes sense. Yeah, so what they're saying here is there's nothing here that constitutes data leakage because all of this is stuff that you will have at the time of prediction, and there's nothing here that's directly related to what the price will be. But it just may not be that helpful of a model.
Yeah.
Does that make sense? I think a good question to ask this person would be how much money they've made with their model. Because
that was a good question.
Yeah.
Good problem.
Yeah, and yeah, so that's a good one. I like that. All right, preventing infections. An agency that provides healthcare wants to predict which patients from a rare surgery are at risk from infection, so it can alert nurses to be careful. They want to build a model. Each row will be a single patient who received the surgery, and the prediction target will be whether they got an infection. Some surgeons may do a procedure in a manner that raises or lowers the risk, but how best can you incorporate the surgeon information into the model? You take all surgeries by each surgeon and calculate the infection rate among those surgeons. For each patient in the data, find out who the surgeon was and plug in that surgeon's average infection rate as a feature. Does this pose any target leakage issues? Does it pose any train test contamination issues? Let's see.
So that's a lot of information to take in at the same time.
It is, and one of the things that makes me concerned about that particular model is there may be other data related to which surgeon is running that is captured by that particular surgeon that may not be captured in total. So like maybe some of these surgeons are specifically ER doctors,
Yeah.
and maybe those are more likely to have infections, or maybe certain surgeons are more likely to operate at night because they're younger and on call or something like that.
Yeah.
And so maybe that has something to do with it.
This is a very tricky one as well.
Pose any train test contamination issues. I don't think at the outset it provides any direct train test contamination issues.
Yeah, I mean, even for just if the questions are target leakage and train test contamination, I don't think so. Except if you want to, when you are calculating the average infection rate for the surgeon, if you want to include the person who is currently, then that would be a target leakage issue. But if you're just taking all his previous patients, then that should be fine.
Yeah.
And I don't see any train test contamination issue.
Yeah,
At least on the first glance, I don't.
I don't think so. But again, we could be wrong. Pause the video, try to figure it out, and then you'll see if you are wrong or right with us. Let's see. All right. So this poses a risk of both, though you may be able to avoid both if you are careful. So this is what we were talking about. The surgeon may capture more data than is just there. So let's see what they say. You have target leakage if a given patient's outcome contributes to the infection rate for his surgeon, which is then plugged back into the prediction model for whether that patient becomes infected. You can avoid target leakage if you can calculate the surgeon's infection rate by using only the surgeon's surgeries before the patient we are predicting for. Okay, so that's what Ravi mentioned. Yeah. As long as you don't include the current patient in this infection rate, then you should be fine there. Calculating this for each surgery in your training data may be a little tricky. You also have a train test contamination problem if you calculate this using all surgeries a surgeon performed, including those from the test set.
Oh, yeah.
Oh, okay. Yeah, so that makes sense. So what they're saying here is if you're taking an average of the infection rates for each surgeon, you have to make sure that you're not taking an average infection rate over your train and test data set. You have to only include your training set. Otherwise, you're implicitly giving your model some information about the testing data set. Again, doing it on a person by person basis looks like it leads to some subtle things that you may not think about ahead of time. So
yeah, and this would again increase your validation accuracy by a lot because you have inherently fed your model some cheat codes about your entire data set and your entire validation. So, but yeah, once it goes into the production, there is a very good chance that it would not do that well.
Yeah.
And it actually might do way worse.
Yeah, for sure. All right, and then this is the last one here. So we're going to build another model for predicting house prices like we've done in a few of these other ones. The model will be deployed on an ongoing basis to predict prices of a new house when a description is added to a website. Here are 4 features that could be used as predictors. The size of the house in square meters, average sales price of homes in the same neighborhood, latitude and longitude of the house, and whether the house has a basement. And you have the historic data to train and validate the model. Which of the features is most likely to be a source of leakage?
For me, it seems the second one.
Yeah.
I mean, because since it's taking average, it seems like the same problem as the earlier one.
The surgeon one, yeah.
Yeah, that if you are taking the current sale price of the house into the average, if you're counting that. Well, that
Yeah.
wouldn't be a sale price though. But even then, size of the house wouldn't change. Latitude and longitude wouldn't change. And how if a house has a basement or not wouldn't change.
Yeah.
I mean, it can change, but if the information that you get from the advertisement, over there, these things should be fairly consistent.
Yeah. I also feel like the latitude and longitude might be a source of data leakage because that would be a specific identifier of that particular house, not just a generic
That's true.
house thing.
That's true.
And anytime we're feeding something that could specifically identify a house or one of our samples, so that's why if you have a training sample, you want to make sure that you don't have like your patient ID, even if it's anonymized. You don't want your patient ID as part of your testing data set. But I don't know. So what are we going to go with? We're going to go with fill in the line below with one of 1, 2, 3, or 4. Let's go with the one that was Ravi's gut first. Okay. So 2 is the source of target leakage. Here is the analysis for each feature. All right, so Ravi was right. All right. I was being a little bit overly cautious, perhaps. So let's see. The size of the house is unlikely to be changed after it's sold. Okay. And typically available when we need to make a prediction. Great. We don't need the rules for when the average is updated. The field is updated in the raw data after a home is sold. Then the home sale is used to calculate the average. So again, this is like the surgeon thing. If you're talking about potentially using the price from the home that sold to predict the price of the home sold, then that's target leakage. Let's see. And then, the latitude and longitude aren't going to be changing before or after prediction. And then the whether or not the house has a basement shouldn't change. All right. So no target leakage there. All right. Well, I'll take it. Let's see what these say here. Yeah, so which of these might be updated? So it seems like
technically the hint that can go for multiple of these fields.
Mm-hmm.
I mean, if you could update your database, you could update whether the house had a basement or not.
Yeah.
Because I think it is difficult, but it is still possible to create a basement after the house has been made, right?
No. Not generally.
No.
It is possible to like make a garage or something like that after the house is built. But yeah. But I do like what you're saying. Like, I think one of the keys for finding out whether or not something's target leakage is just that of when do you find out that piece of information?
Yeah.
If you can only find it out after or something about the predicted state might feed into that field, then that could be an issue. So you would have to make sure that any averaged features, like the average sales price of the neighborhood, would have to be calculated prior to making the prediction.
Yeah, and so this takes you to an interesting point where you, as a data scientist, have to be very careful about how the data is gathered for the data set that you're planning to use. Mm-hmm. And at what point do this make those changes? Like in the very basic example that they showed for target leakage, sometimes just knowing the name of the field is more than enough, like the one over there, that if they got shot for pneumonia or not.
Mm-hmm.
But yeah, sometimes you have to be very careful in finding out when when was the point that did they update the data set? So
Yeah. All right. Well, so that was data leakage. Let us know if you guys have any questions. As you saw, we're still figuring this this stuff out. So feel free to come into office hours or leave a comment below if you want to have further discussions on this, or if you want to talk about something that you think might be data leakage, and we can at least have a dialogue about it and maybe figure out whether or not your data is rigorously set up for generalizability and reproducibility of your model. But yeah, thanks for tuning in.
thank you.